Integration by parts. If we had the integral e to the x dx, we could evaluate it because we would think of what function's antiderivative is e to the x, and we know that's e to the x, and then we could put plus a constant on here. But what if we had the integral of x e to the x dx? Now this makes it a lot more complicated. Gut reaction might initially be to find the antiderivative of each piece, but we can see if we were to check this by differentiation, we should be able to get this function back, and we do not, because you would have the product rule, first times the derivative of the second plus the second times the derivative of the first, and that certainly does not give us our function back. So how do we integrate? We have this product x e to the x dx. We are going to have a method called integration by parts, and first we're going to look at it for indefinite integrals. And so if we have two functions of x, we have u of x and v of x, and have their product, we're going to look at that derivative, and that's just simply the product rule. If we called them f and g or u and v, it works the same. So the derivative of these is first times the derivative of the second plus the second times the derivative of the first. Now we're going to integrate both sides with respect to x. Now this left-hand side, we can apply the fundamental theorem of calculus, and that will leave us u of x, v of x. And the right-hand side is the integral of a sum, so we can write it as a sum of two different integrals. We've got the integral of u of x, v prime of x dx, plus the integral of v of x, u prime of x dx. Now I'm going to solve this for this piece, so we will write it first. So we have the integral of u of x, v prime of x dx equals u of x, v of x, and then this will be subtracted so that we can move it over there. So integral of v of x, u prime of x dx. And then just one more thing, if we have this derivative v prime of x dx, this is dv, and this u prime of x dx is du. So we could express this just a little simpler. And then we're also going to express it by leaving the of x's off. That just signifies that they're functions of x. And here we have the integration by parts. Suppose u and v are differentiable functions, then the integral of u dv equals uv minus the integral of v du. And this is something that we're going to want to memorize because we're going to utilize it a lot. You saw where it came from, but if we kind of put it in this little simpler form and we memorize it, we're going to be able to integrate things like this. This one happens to be the product of two functions of x, and what we're going to do is we're going to identify our u and identify our dv, and we're going to list those. U is x, and dv equals e to the x dx. Then we're going to find du, so if we do a derivative here, that's just going to be dx, and we're going to identify v, so we want to do an antiderivative, so v is going to be e to the x. Now we're ready to apply the integration by parts formula to this. We had this left-hand side integral of u dv, so that will equal uv, u was x and v was e to the x, so x e to the x, minus integral of v, that was e to the x, du, du was dx. Now we need plus a constant, we'll call it c1. I'll do this one time and then we won't do this. After this we'll always just do it on the end combined, because we can see that here if we had x e to the x, and now we can evaluate this, this will be minus e to the x, and then we could have plus a constant that we had here plus a constant for the second one. So we're not going to bother to write those both times. We're just going to stick one on the end and call it c. So our final answer is x e to the x minus e to the x plus c. We can see that if we wanted to check this, we could take a derivative and we should get the original function back. So looking at this first term, it's a product rule. First times the derivative of the second plus the second function, which is e to the x, times the derivative of the first function, which is 1. And then minus the derivative of e to the x is e to the x, and of course the derivative of the constant, it's gone, and we can see these cancel, and we do in fact get our original function back, so it checks. Now what if we had a definite integral? Well, it's going to work the same way. We're going to have u and b differentiable functions, but if we want to integrate from a to b, u of x, v prime of x dx, we're still going to have uv, but we're going to need to evaluate it from a to b, and then minus integral, and we'll need the limits of integration, v du. So same formula, just applying our limits of integration. So let's look at an example. Now, when looking at this one at first glance, you might not think you'd need integration by parts, but if we wanted the antiderivative of the natural log of x, I don't know what that is. So what I'm going to do is I'm going to call this u and this dv. Now remember, our formula was integral of u dv equals uv minus integral of v du. That's what I memorize. That's not in definite integral form, but we can easily put limits of integration in there if we need to. Okay, so we have our u was natural log of x and our dv was dx. So what is du? Derivative of natural log of x, 1 over x, dx. And what was our v? If our dv was dx, then our v must have been x. So now that we've identified our pieces, we can go ahead and apply the formula. So we need uv, that's ln x and x, so we're going to write x ln x, but this is a definite integral, so that'll need to be evaluated from 1 to 2, minus integral, and that's from 1 to 2, of v du. v was x, and du was 1 over x dx. Okay, so we can simplify this a little bit, and we will have x ln x. Now I'm not going to put the evaluation part because I'm going to go ahead and work this integral, and then we'll put the evaluation on the end. So this is just minus the integral from 1 to 2 of dx, so that's just going to be an x, and then we need to evaluate this from 1 to 2. So we have 2 natural log of 2 minus 2 minus 1 natural log of 1 minus 1. As we simplify that, the natural log of 1 is 0, so this piece is gone, and we have 2 natural log of 2 minus 2 plus 1, so minus 1. So there's our solution. Now, in looking at this, then, if we wanted to have a formula for the integral of the natural log of x, we could figure out what that is, because we essentially did that. We had it for a definite integral, so we ended up, with just a numerical answer. But if we wanted to do it for an indefinite integral, here is the piece that we had when we applied the integration by parts, and then we would just need a plus a constant on the end. So the integral of the natural log of x dx is x natural log of x minus x plus a constant. If you have that memorized and you need to integrate natural log of x, you could spit that out, but likely down the road you won't remember exactly what that was, but you will know how to integrate by parts, and so you could easily come up with that again.